Good day, friends. Today we are going to consider some model on impossible constructions. Now, what do we mean by impossible constructions? In mathematics, constructions are those which can be made with the help of a compass and an unmarked ruler. So, for example, this will not do, but something like this, where nothing is marked, you can simply rule a line, you cannot measure. We have done some such constructions like bisecting a line segment, bisecting an angle, drawing a perpendicular to a line segment, and so on. But what is important and nice about these three constructions is that they have been proved mathematically, rigorously, that they cannot be done with the help of just a ruler, unmarked ruler and a compass. So what are we going to do about it? Well, they are impossible mathematically with the help of these two instruments only. We shall try to construct these three things in some mechanical way. So we take up the first such construction. First impossible construction, it is that of trisection of an angle. The impossibility lies in trisecting an angle. Given any angle, you can always bisect it. You can trisect some angles, but not all. And therefore, we cannot say that every angle can be trisected. That has been proved, as we just noted. We tried to trisect a given angle. Here is an angle, given angle, and we try to trisect it with the help of some mechanical models. Okay, the mechanical model that we have here, or rather simply the model, consists of these two parts. There is a strip at the top of which there is at the end of which there is a semicircle, and there is another again straight strip. What we do is, we take this strip and put it on the given angle in such a way that the center of the semicircle will lie exactly on the vertex of the given angle. Alright, now what we do is, this is the given angle alpha. We want to construct an angle theta whose measure when you take 3 times will be that of alpha. And this is the construction. The construction is very simple. It's like this. You take a strip. First of all, of course, we mark this point here, where the semicircle intersects the second side of the angle. The first side is, of course, along the diameter. And along this strip that we have taken, what I have done is, I have marked a point here which is precisely the length of R. See, I am putting this corner at the center, and you will see that this length is exactly R. I have taken R here. This much length is R. Okay, now what we do is, we want to move this strip. But not just any way, there are certain conditions. First condition is that this corner should always lie on this strip, horizontal strip. The second condition is that it should always pass through this point here. Which point? Where the second side of the angle intersects the semicircle, this point. Okay, now that is not enough. We have got these two. There is a third condition, and that is where you need to slide the strip. You slide it all the way so that every time the two conditions are satisfied. But we have marked here on this strip a distance R. If you recall, we had marked this distance R. This point should lie on the semicircle. So now we keep these two fixed already there, and then now move it in such a way that this point lies on the semicircle. It also passes through this point and it also touches this. And then we mark this point here. This is the point here. Okay, so that is what we did. Now, we join these two. The point on the semicircle and the side of the angle and the point that we obtained. Here is the point that we obtained. And we claim that if this angle is theta, alpha is going to be 3 times theta. So our construction is over. We have constructed an angle which we say that 3 times this angle will be alpha, or it is the trisection of alpha. Now, we have to prove our construction as usual. And so in order to prove it, we draw here some things. For example, we simply draw what we have taken. We have taken this semicircle. We draw that semicircle. Okay, so this is the point where our this strip was cutting the semicircle and the side of the angle. Now we also join this. Okay, now suppose the length of the semicircle, we don't know how much it is, we call it R. Then this is R, this is R, and this is R because they are radii. This also is R. Why? Because we have taken it here. If you recall, this is what we have taken. This is R. So this is also R. So all these lines, segments which I have marked are length R. Now look at this triangle. These two sides are equal. This angle is theta, which means that this angle must be theta. Okay, if this is theta, that is theta, the external angle of that triangle will be 2 theta. Now, this is an isosceles triangle here, over here. One angle is 2 theta, so the other angle, base angle, is also 2 theta. And now, look at the angle alpha. In this big triangle here, the point on the circle and the side of the angle, the center and the point which we obtained. If you look at that triangle, alpha is the exterior angle. It is equal to the sum of the two interior angles. That's 2 theta plus theta. And so we have alpha equal to 3 theta. So we have been able to construct an angle such that it is 1/3 of alpha. Well, okay. Thank you.